So, next topic is solar pond. Let's define a solar pond. A solar pond is a large, shallow pool of salt water that is used to collect and store solar energy. Now, as you know, every water body, let it be a lake or a pond or a river, sea, ocean, the top layer is the top layer of water is generally hot during the daytime. That's because the top layer of the any particular water body absorbs heat, and thus you get hot water. But in this particular solar pond, first of all, solar pond, there exists no real or natural solar pond. All are man-made, that is artificial solar pond. So water body is created, and this particular water body is called a solar pond, and it has three zones. One is the top zone. As you can see, it contains fresh water. When exposed to sunlight, it can heat up to 30 degrees centigrade. Next is what you see is the gradient zone. Gradient zone is the one between the top zone and bottom zone, and the temperature can go up to 70 degrees centigrade. And the bottom zone, the temperature over there can go up to 100 degrees centigrade. Okay, so this actually happens because the concentration of salt increases as the layers go from top to gradient to bottom. That's because salt water has a capacity of storing the heat that is absorbed by the sun's rays. uh, this particular figure, as you can see, the top layer is this is nothing but the top zone, this is the gradient zone, and this is the high salt content hot brine, or nothing but the bottom zone. So here in this particular thing, as you can see, as I read this, the solar pond works by allowing sunlight to penetrate the top layer of the pond and heat up the water. As the water heats up, it becomes less dense and rises to the surface, where it cools and sinks back down to bottom of the pond. This convection process creates a stable temperature gradient within the pond, with the warmest water at the bottom. So here, as you can see, the sun's rays come to this particular layer, that is the top layer. Then it is passed down to the bottom layer. The heat exactly is passed on because the salt content increases from the top zone to the gradient zone to the bottom zone. Okay, the bottom zone has the highest salt content. So now when the water, exactly when it gets heated, when it tries to escape from this particular bottom zone, this gradient zone does not allow it to go. So let's exactly see the top zone. It has salts, and as you can see, till 30 degrees centigrade the temperature will be there. Next we can see this gradient zone. Okay, that acts, as you can see over here, this portion of solar pond technology is a thermal diode. It absorbs heat from the top zone and sends it to the solar pond's bottom zone. So it acts as a thermal diode. So diode, if you couldn't see in this electric and electronics engineering, it allows the current to flow from one place to another, but it does not allow the current to flow from the other region, or in a two-way flow, or two-way flow is exactly not allowed if you're talking about only the positive and negative. But you have to understand that due to this, as the solar pond or the gradient zone acts as the thermal diode, it only allows heat from the top zone to go to the bottom zone, and does not allow the heat from the bottom zone to escape to the top zone. So hence it acts as a thermal diode. Now this solar pond bottom, it's made up of materials such as concrete, fiberglass, or plastic. The reason, because if it is made of just mud, then the heat which comes to the bottom zone will escape, or it will exactly there will be actually heat loss. Hence these materials such as concrete, fiberglass, or plastic, they do not allow the heat to escape from the bottom zone.